UNF Loader now supports USB debugging using GDB, so let's take a look at how to get that working. First, go to the UNF Loader repository on GitHub, link should be in the video description, and download the latest release. You should be using version 2.1 or later. Click here and download a binary for your specific operating system. In my case, I'm using Linux, so I'm going to download the Linux binaries. Also, I'm going to download the compiled examples and the source code. We're going to need all three of these. Now, I'm not going to show how to get UNF Loader properly installed. You can do that by going here to System Requirements and reading what's required for your specific system. But I will show you how to test that UNF Loader is properly working. Now, in the case of Linux, you would probably use this install script here as outlined in the instructions, and the UNF Loader binary should be installed somewhere in your operating system. Now, I'm going to grab one of the compiled examples. In this case, I'm going to grab the UNF Loader example 4 since it's the most complete one, and I'll drag and drop it into my home directory. And now that that's done, I'm going to open a terminal and I'm going to call UNF Loader -R for ROM, UNF Loader example 4, and -D to run in debug mode. Now, in order to upload ROMs using USB, it's different depending on which flash cart you are using. If you're unsure how it works, you should first start UNF Loader with the help command. And over here, you're going to have instructions on how to upload ROMs using USB on your specific flash card. In my case, I'm using the 64 drive, so I would press 1. And over here, it tells me how to upload for my specific flash card. Read those instructions and familiarize yourself with the process. So, now that I know how to upload ROMs, I have my N64 turned off in the 64 drive's case. I call UNF Loader -R UNF example 4 -D. I go ahead and I upload the ROM. I turn the console on. And I'm going to open VLC since I'm using a capture card. Ideally, I'd be doing this through OBS, but since I'm using OBS to record the screen, I'll have to use VLC instead, which won't be as good as OBS. Just going to quickly go here and disable caching, and I'm going to set the resolution to something smaller just so that VLC doesn't lag a lot. So if I go ahead and I click play, alright, we can see our ROM here in action, even though it looks a little bit distorted, but that's alright. So just to quickly check that everything's working, I'll just run through each command. I'll type in ping, the console responds with pong. I'm going to type rotate, and the square is now rotating. I'm going to call color, I'm going to give it a random color, maybe red. Alright, and well, I can't really run the texture command since I need the source code to do that. But we've at least confirmed that USB is working as intended. So I'm going to kill UNF Loader by pressing escape and turn the console off. So we've confirmed that UNF Loader is working. Next, we need GDB. Now, I'm not going to get into how to download GDB for your specific operating system, but I am going to outline something very important. If you just install plain GDB, you're going to have a bad time, because plain GDB is only designed to work on your computer. And you can check this by doing set architecture, and you'll get a list of valid architectures. As you can see, this only really supports Intel/AMD instructions, which in the case of the N64 that uses MIPS, this will not work. So what you actually need to install is GDB multi-arch. In GDB multi-arch, if you do set architecture, it'll list a lot more architectures, with the most important one for us being MIPS 4300, which is what the N64 uses. So it's important that you install GDB multi-arch in order to get UNF Loader to work properly on the N64. Okay, so once you have those two things installed, then you can actually start playing with GDB on the N64. So I'm going to run through the 3 most popular N64 development setups to see how to get it working on each one. This will be libultra on a virtual machine or old hardware, Modern SDK, and libdragon. I've gone ahead and I went to examples, libultra, and I extracted the command interpreter example into my Windows XP virtual machine. I'm going to be using this example instead of setting up an already existing project just to make things easier. But for your specific project, if you haven't used the USB or debug library before, then all you have to do is to go to the USB debug library folder and drag and drop these 4 files into your project. And then in your makefile, you add them to your list of source files. It's also important that your project is compiling with debug information and with no optimizations. In the case of this example, that's already set up. So I'm going to close this. Now, in order to actually enable GDB for our ROM, there's 2 important things we have to do. First, we have to go to debug.h and we'll need to set the use RDB flag to 1. It's also super convenient to set auto poll enabled to 1 as well. You don't have to, but I would really recommend it. Save the debug.h and then go to your project main.c. In here, you need to call debug initialize. This is what's actually going to enable GDB to work, and don't forget to include debug.h. Obviously, if you've already used my debug library in the past, then you should already have all of this set up. You just need to go to debug.h and enable the autopoll flag and the RDB thread flag. So with all of that out of the way, I'm going to go ahead and compile the ROM. And let's test it on our console. Okay, so we're back here in Linux, and now let's try to debug this with GDB. So I'm going to open 2 terminals. Then I'm going to put this one on the left, and I'm going to put the second one on the right. In this first terminal, I'm going to call UNFLoader with our ROM, UNFLoader example 4. And now, instead of running the D flag, I'm going to call the G flag for GDB. And we went ahead and we've uploaded our ROM. Now, in this other terminal, we're going to call GDB multi-arch, and we need to provide the elf file. This should be this out file here, which contains all of the debugging information. So I'm going to call unfloater.out. And you should see here reading symbols. Now, because we are using an ancient version of the GCC compiler, GDB isn't going to be a great experience because it's missing a lot of debug information. In fact, GDB even struggles to detect what's in this elf file. For instance, if we type set architecture and then we type auto, since it's automatically selected, we're going to notice that it actually says MIPS 3000. This is wrong because we're on MIPS 4000. So we need to correct this manually by calling MIPS 4300. So now the architecture should be set properly. So I'm going to turn the console on. We should get a notification here that the main thread has been paused and it's waiting for GDB to connect. And if we look here in VLC, we can see that now we have a black screen. Okay, so we're ready. So let's connect by calling target remote, and then we give it the address of GDB. In this case, we've opened a GDB server on this specific address here. So that's 127.0.0.1 8080. All right, and we're seeing some communication, and we can see that we have paused in this specific function here. If we do a backtrace, we can find out a little bit more about this. Okay, so our project started over here, then I went to the main proc, then I called debug initialize, and that sent a message, and that message then started a thread. And this is where our main function is paused at currently. Okay, so let's do some debugging, and let's set a breakpoint on stage 00 draw. All right, so we set our breakpoint, and let's type C to continue. Okay, so we hit the breakpoint. We still have a black screen, so I'm going to continue again. Okay, now typically with GDB, you would be able to do something like list to see where specifically the game has paused in our source code. But GDB is struggling to do that because, again, the compiler we used is so old that it doesn't contain the important debugging information that a modern GDB requires. And so all that we can really do is assembly level debugging. So that includes like listing registers to see what's the current status of the program. We can also list our floating point registers if we're so inclined. And then we can disassemble. So we can see that our project has paused at this instruction right here. And so let's do some stepping. I'm going to step, let's say, 4 times so that we stop at this jump instruction here. And let's double check that we're in the right spot. And there we are. Let's do another step in. Okay, and now we're inside of the RCP init. And we can see the disassembly of that specific function. So obviously this isn't great, but we can still do breakpoints, we can still step, and we can still try to figure out what's going wrong with our project. And of course, we can then delete the breakpoint and then press C to continue. And our ROM's just going to execute like normal. So we can type all the commands that we tested before, like rotate, and now our square is rotating, and then we can do color, give it some random value. And then we can pause this at any time by pressing Ctrl C. And we can see that we paused somewhere in the main proc. Now usually when you pause, it's going to end up somewhere random, likely something that's not even in our source code, like something that's internal to libultra, so we won't really be able to do much useful things there, but we can still at least set breakpoints while the program is paused, so that we can then work through our specific code. Okay, so that covers all the important stuff that I'm not going to cover in the GDB section, because the GDB section is more focused on modern SDK or LibDragon, which has a proper debugging experience. Alright, so let's see how to get GDB working on a modern SDK project. Like I did in the previous section, I went ahead and I went to examples, libultra, and I extracted the command interpreter example, which already has the USB and debug library included. If you don't have it in your project, all you have to do is to go to the USB and debug library folder inside of the source code zip, and you can just extract them and put them in your project. And then in your make file, remember to add them to your source files. Another important thing is that you also need to make sure that your project is compiling with debugging symbols and ideally with no optimizations. You also want to double check that your linker script is not discarding the debug sections, as we're going to be needing those. Okay, so we've gone ahead and we've added the USB and debug files. And we're going to go to our main file and we're going to initialize the debug library. This is as simple as calling debug initialize, and make sure you include the debug.h. Lastly, to actually enable GDB, we have to go to debug.h and we have to change two flags. First, we have to change the RDB thread flag here to 1 in order to actually enable GDB. And ideally, we also enable auto polling. You don't have to, but it's highly recommended to do this. Once all of that is done, we can go ahead and just compile our project. And now we should have our elf file, which contains the debug information, and our ROM. So let's go ahead and open two terminals. In this first terminal, we're going to upload our ROM using UNF loader. So UNF example 4.z64. And we need to set the G flag, not the D flag, the G flag for GDB. So I've gone ahead and I've uploaded it, and I'm going to turn my console on. And we should be getting pausing main thread until GDB connects and resumes. And if we look here in VLC, we can see that the screen is pitch black because the game is currently paused at boot. So let's actually run GDB. So I'm going to call GDB multi-arch, and I'm going to also append the UNF example elf file. So if everything is correct, this should say reading symbols from UNF loader example 4. It should not say no debug symbols found. If it says that, then you did something wrong. So this managed to read our debugging symbols. So we're good to go ahead and connect to the console. To do that, we type target remote 127.0.0.18080. This address here is the one that's over here that says starting GDB server on blah blah blah. So we do that, and we should see some communication. And now we can see that our project has been paused, so we're going to backtrace just to find a little bit more. And we can see that we started by dispatching the thread. It created our main proc, which called debug initialize, sent a message, and then that started a thread. And paused everything. We still don't have anything, so let's proceed to continue. And now our ROM should be working as usual. And we can press Ctrl-C to pause it. So now it's paused, and we can press C to continue again. We'll look into actually how to debug with GDB in the last section of this video. Lastly, let's look into getting GDB working on a LibDragon project. In this case, I'm using the command interpreter example from examples LibDragon command interpreter, since this already includes the debug library. If you're doing this for your own project, then all you have to do is go to the USB plus debug library folder and drag and drop the debug.c and .h into your project. You don't need the USB.c or .h, as these should be included with LibDragon. Although if you do want to update to the latest versions of the USB libraries without updating LibDragon itself, then you can just go to the LibDragon source folder and you can drag and drop the USB.c and drag the USB.h into the includes folder, remembering to remove the comment inside of USB.h that disables LibDragon support, and then recompiling LibDragon. Once you've dragged the debug library into your project, go ahead and open your make file, and remember to add it into your source files. And make sure that your project is compiling with debugging symbols and with no optimizations. Lastly, two things you need to do in order to get your debug library working. Go to your main.c and include the debug library, and add debug initialize in order to actually initialize the debug library. Then to get GDB actually working, you have to go to your debug.h, and you need to go here to where it says use RDB thread and set this to 1 in order to enable GDB support. I also highly recommend going to here where it says auto poll and enabling this. You don't have to, but I highly recommend it. Once both of those things have been done, you can simply just compile your project. And if we go into our build, our debugging symbols should be right here, and our ROM should be right there. Okay, so I'm going to open a second terminal. I'm going to push this to our right. In this first terminal, I'm going to call UNF-Loader, and I'm going to launch it with our ROM. And instead of using D for debug, I'm going to use G for GDB. Now I'm going to turn the console on, and you'll see pausing main thread until GDB connects and resumes. On our TV, you'll notice that we just have a black screen. This is normal since the game is paused and it's waiting for GDB to connect. Next, we want to go to GDB multi-arch, and we need to load our debugging symbols. So that should be in our build UNF-Loader example3.elf. You should see reading debug symbols from build UNF-Loader elf. It should not say no debug symbols found. If it says this, then you have messed up at some point. Once the debug symbols have been loaded, we just need to connect to the N64 by doing target remote 127.0.0.18080. This address here is this address here where it says starting GDB server. So we're going to go ahead and connect, and we'll see some communication happen. And we can see that our project has paused on debug thread RDB pause. If we look, we still have a black screen, and that's fine. So let's type C to continue. And it looks like our ROM should be working. We can type in move. Okay, our square is moving. Ping works, and color 25500. Our ROM is basically working as we expected. But since we have GDB, we can Control C to pause the project, and you can see it's paused. And we can do stuff like setting breakpoints and whatnot, and then pressing C again to continue, and then blah, blah, blah. If you haven't used GDB before, we're going to cover that in this next section. All right, let's use GDB to help us diagnose a crash in a ROM. Over here, I have the thread fault sample from UNF-Loader's examples. We'll start by compiling our project to take a look at what's going on. Let's upload the ROM using UNF-Loader in debug mode. And boot the console. Now let's take a look. Alright, so we crashed with a TLB exception on load or instruction fetch, and that happened at around this program counter value here. So let's use GDB to help us diagnose that a little bit further. So open debug.h and enable GDB thread as well as auto polling. Now I'm going to put this down here. I'm going to open a second terminal. I'm going to put that over here. And I'm going to put this up there, and I'm going to turn the console off. I'm going to do a clean make just to be safe. And now we're going to upload using UNF-Loader, but with the G flag for GDB. So turn the console on. All right, we've paused. So let's open GDB multi-arch and feed it the ELF file. And now let's remote target. Okay, let's continue. And we've crashed. So I'm going to Control C, and let's use GDB to help us figure out what this address means. I'm going to do info line, and I'm going to dereference this address. Now, we were unlucky because GDB wasn't able to tell us what this address actually is, but we do at least know that it's in stage 00 draw. So we're going to use a disassembly just to help us hone down on which line it's specifically crashing in. Okay, so we're seeing RCP init, but this is happening at 26, so we're not quite there yet. For reference, that would be this RCP init here. So let's continue a little bit more. Okay, we see an OS virtual to physical, so it's this call here, but that's still at 26. So let's keep going until we find 27. Okay, we're at 27, but we need to be at 4FC. Okay, so we are crashing at this line over here, and that line is happening a little bit before debug assert, which would be this line here. So we weren't able to isolate specifically which line it's happening in, but we at least know it's happening somewhere between here and here. It's in this block. So let's use GDB to try and figure out what line corresponds to what address. Let's maybe say line 230 here. All right, so line 230 starts at 26, so we're not there. Let's maybe say 33. Okay, then maybe 240. 240 is at 27. Okay, we're getting close. Let's try 243. 27 for EC. We want FC. So the next line would be 49. But this line's already way too far. Okay, so the crash is happening somewhere here in this for loop just before this line. But because we did look through this code, maybe GDB now is able to tell us a little bit more about that address. So let's do info line and try to read that address again. All right, and now GDB was actually able to tell us that the crash happened on line 233 of stage 00.c. So the crash happened here in the start of this for loop. And the only thing that would really cause a TLB exception on loader instruction fetch would be this dereference here. So something is wrong with this SPR value and we have to figure out what. So what we should do is we should reset the console. And let's continue, but I'll try to pause just before the game crashes. Okay, we managed to pause just before we crashed, and now let's place a breakpoint on the line before the error. So let's place a breakpoint on stage 00.c, line 232. Okay, let's continue. Okay, so we braked at this line here. Let's take a look at the local variables. So I'm going to do info locals. Okay, so this value of SPR, we have to be careful because it's actually outdated. We breakpointed at this line, but we haven't actually executed it. So this SPR is pointing to its previous value. Okay, chucks contains these two structures here, and we can also see the value of I and j. We can find out a little bit more about chucks by doing p and then chucks. And let's take a look at chuck1. Okay, so we're seeing that chuck1 is a pointer to a chuck type. So let's dereference the value. And now we can see the value of x, the value of y, the direction, state, frame, subframe, and the frame time. And it's pointing to this kick animation here. But there's a little thing here that catches my eye. This frame value 5 here. If we look over here, we have this kick animation. And if we go back to GGB, we can see that it's pointing to frame 5, which actually means frame 6 because these are 0 indexed. And if we look, we have 0, 1, 2, 3, 4, 5. Oh dear. Looks like this frame value is pointing way outside of this structure here. It's very likely that if we continue now, we're going to crash. So let's step a single line. So we're currently at the for loop. Let me just take a quick look at the value of chucks. That hasn't changed. But what has changed is the value of SPR, since that line has now executed. So let's take a look at it. And oh dear, looks like SPR now contains a null pointer. And I bet if we do another step, we have crashed. So the mistake here is that this should be a 5 because we only have 5 frames of animation. So I bet if I correct this and I recompile the ROM, so I'm going to turn the console off, kill UNF loader, that killed the remote connection, I'd run make, upload the ROM again, turn the console on, we press C to continue, Oh, whoops, sorry, we disconnected, so we have to target remote. We type C. Right, we have the breakpoint, so we have to delete it. And it looks like we've resolved the crash. Hopefully this was informative enough to help you get your bearings around GDB. Obviously, there's a lot more that GDB is capable of, and you should definitely get yourself familiarized with GDB if you're going to be using it. You also don't need to use it in a terminal like this. There are GUI versions of GDB, or other debuggers that use GDB's communication protocol. I'll leave that as an exercise for you.